Our next great discovery started in the 1890s with the discovery of an unknown radiation called X-rays. It caused a sensation, and scientists immediately began looking for other substances that emitted strange, perhaps valuable forms of radiation. Over the next several decades, a number of scientists investigated the phenomena and together ended up shedding light on one of the great scientific sleuthing episodes of modern science. French physicist Henri Becquerel made the first significant breakthrough. In 1896, he conducted a series of experiments to see if various minerals emitted radiation. One of the minerals he happened to test was uranium. Becquerel's technique was to place different objects on top of an unexposed photographic plate, still wrapped in protective black paper. He would sprinkle the uranium onto another piece of black paper, then enclose the object between the uranium and the photographic plate. Later, Becquerel would develop the plate, and without fail, a ghostly photographic outline of the object would appear. From these experiments, Becquerel was able to prove conclusively that he had found a source for the mysterious radioactive rays that everyone was looking for. That source was uranium. From Becquerel, the investigation of radioactivity was taken up by Marie Curie. Curie and her husband Pierre undertook the job of isolating whatever elements were responsible for the radioactivity in uranium ore. For 2 years, the Curies boiled, sifted, filtered, and processed several tons of uranium ore. Finally, they succeeded in isolating 2 new elements contained in the ore, which they called polonium and radium. Marie Curie concluded that radium was 1,000,000 times more radioactive than uranium. More importantly, she determined that the mysterious form of energy which enabled radioactivity to penetrate other materials was not the result of a chemical process, but seemed to be atomic in nature. Unfortunately, her discoveries came at great cost. The dangers of being exposed to radioactivity were still unknown at the time, and in 1934, Marie Curie died of leukemia, believed to have been caused by radiation poisoning. Even the notebooks that she used to record her observations are still considered too radioactive to handle. It was the atomic nature of radioactivity that eventually attracted the interest of physicist Ernest Rutherford, whom we already met in the discovery of the electron. Rutherford found that radioactive material goes through a natural process of decay. As it moves through the process, the radioactivity spontaneously emits unstable and highly charged energy particles with the power to penetrate matter. Rutherford called them alpha and beta particles and gamma rays. Since those discoveries, we've learned a lot about radioactivity, the dangers as well as the benefits. Radioactivity has given us medical imaging, a treatment for tumors, a method for calculating the age of the Earth, and a power source for our spacecraft to explore the solar system.